Good morning. I don't know where's everybody at today.
I think it's just us two.
So far, I am. I'm having to. I'm converting. Get rid of some of this stuff. I've got a conversion running from my previous meeting here, so I'm hoping my computer don't crash with me. And I know I've got a lot of things open. Let me just. Yeah, okay. Get rid of some of this stuff. Maybe it'll run smoother. All right. So, good morning, Linda. I'm just picking on you. There, it changed over to Larry now.
Morning, Eric.
It showed up as Linda there at first.
That's the computer she uses most of the time.
That's fine. That's fine. How have you been able to download AutoCAD successfully?
I haven't. I checked the system requirements for that, and I don't have a machine that is up to date enough to do that.
Boy, that's going to be a problem. Huh. Okay, I'll have to do some soul searching thinking on that. Well, for right now, what I want you to do is kind of follow along. Of course, this is being recorded, and hopefully you can come back and I can help you get that sorted out, and we can get you working on this. So, in AutoCAD, and of course, Larry, you can always just draft stuff and sketch it out for right now. If you need to, just using whatever design tools you have at your disposal. Piece of paper and a pencil, of course, works out great. Or a grid pad or something like that will be fine. What I want to do is start and kind of talk to you guys about. Well, first of all, let me go into a little bit about CAD itself. So when you open up CAD, if you go and hit a new drawing and you open up whatever the first thing pops up there, you're going to find out that you have. Let me close some of this stuff so that I can. When you guys go back and look at the recordings, you can see it. And so when you first open up CAD and you go to make a box, for instance, you'll notice that your cursor is going to pop up stuff like 3.49. And that is because CAD was originally invented to do mechanical drawings. So these are in an inch. These are decimal inches. So when you're opening up a new drawing, when you click on new and it opens up, you'll come down through here and you'll see something here called traditional eye arch. And what that means is imperial architecture. So if you click on open that, it will bring you to this this layout. And we just don't need to go that. We need to start over here in the model. So down here at the bottom, you're going to you can go to the layout, or you can click on model and you can find things like this. So what that means as far as imperial arch, meaning that it is imperial units, feet and inches, and it is in the architectural form, not in the mechanical form. So when this particular format is set up for the use in architectural drawings and so forth. Now, when we were clicked on that new up here again, then you'll also see that there is M arch. So that's metric arch. And then, of course, you have imperial manufacturing, metric manufacturing, and a whole bunch of other stuff. But these are the four main ones that that pretty much are used in the United States. I-arch, imperial arch, imperial manufacturing, metric arch, which is out, anytime we do any kind of architectural drawing outside or for the outside of the United States, and I'm talking about Canada and Mexico as well, then they use the metric system. We're probably one of the last that use the imperial units. And then you've got metric manufacturing. Now, imperial manufacturing is almost non-existent, even in the United States. Most of the machines that we purchase to build car parts, to build whatever, are, they are going to be in a metric form. They're not going to be in imperial form. So that we had I don't remember if you guys remember or not, but a couple of years ago, we had a rover, a Mars rover, that it pulled out of its little casing once it landed on Mars, and it went about 2 feet, and that was the end of it. It stopped dead, didn't move. The reason being is one of the engineers had built it, or the machine had been built in metric form, but then whoever wrote the program for it to run was written in imperial form. So, when it pulled out of its landing shell, it probably may have been set for meters, thinking that it was going to go out about 3 meters, but instead it went about 3 feet, and that was the end of it. So they had to go back and rewrite the program to make sure that the Mars rover worked the way it should. So for this class, we're going to be using the I-arch. And so when that's said, again, when we go to get this, we're going to be ending up, we're going to seeing dimensions in the feet, inches, and fractions of an inch format. So to start with, I don't know why this is, oh, it's finished. Good, good, good. So to start with, what I want you to try to do is, and Larry, just because you don't have CAD, I don't want you to, think that you don't have to do this stuff. I want you to draw lines and circles and squares and so forth the best you can. All right. So I don't, you may not have a T-square. Any of you may not have a T-square, and you would be surprised at what you can do with just, a regular ruler. Okay. So, especially if you got grid paper, these regular rulers, they got a metal edge on most of them, and they're feet, or excuse me, they're inches, and you can do a lot of stuff with this. So right quick, while I'm thinking about it. So to kind of explain to you, well, I thought, where's my stuff? It's probably hanging on the walls. I don't see it anywhere. I had a roller ruler. Really neat to have, and I'm not seeing it anywhere. Give me just a minute. Let me find my other picture. Yeah, there we go. Well, there's the box. That's in there. Okay. All right. So this is a rolling ruler, and a rolling ruler has these little wheels on it. So that means when you're rolling across a surface, it will keep it from, doing this. These little rubber wheels on there keep it from moving from side to side so that you can get your lines parallel. This is a real cool and handy tool to use. And if you don't have something like that, I have used a framing square. I'm trying to find out. I think the cat has knocked my T-square off of its hanging place. Yeah, it's back there and I can't get to it. Sorry. So you know what a T-square looks like, and those can be used at a desk or kitchen counter or so forth, and they help you also keep things parallel. Everything back in here. So the next thing I want to talk to you about was the architectural rule. And an architectural rule has inches, on one side. And then on another side, which is, I'm going to go with the most common, then you have a 1/4 inch scale. So this 1/4 inch, that's a 1/4 inch per foot, or excuse me, a 1/4 inch. Yeah, a 1/4 inch equals a foot. So 4 of these, that's an inch. And so 4 feet equals an inch. So you can kind of see how that works. And it's broken down into inches there. This is the same scale here, the 1 inch scale, which is on the other side. And you can see that it's broken down into inches. It's kind of blurry. It's not wanting to focus right. Let's see if I get behind it, if it focuses on that. So it's broken down into 3, 6, 9 inches, but then it goes and breaks down into even further fractions of an inch. You go over to the 3 inch and you'll see. So on the 3 inch scale, it gets bigger. So this is 3 inches is equal to a foot. So this is 12 inches here. And then this is broken down into inch, half, quarter, inch, half, quarter, eighth. So each one of these little bitty lines is an 1/8 of an inch. And it's hard to see those little bittiest lines. So we can't draw. So when we're thinking about this drawing here, this is a house. Sorry, wait a minute. You can't see that. Share screen. So, obviously we can't draw to full scale. Otherwise this, we'd need a piece of paper that was 50 foot long. So we have to draw it to a scale. And when we're talking about how to draw these, then we have to, take into consideration the thicknesses of the walls and all the material and stuff that goes along with it. So one of the things that you can kind of start with here is to get yourself oriented with what goes into a house and how the material is. So I think most of you guys have already had some sort of either blueprint reading, construction classes, or something before now. So you understand the makeup of a wall. So this is a typical stud wall where we have a double top plate. We have a single bottom plate. We have 1/2 inch drywall on the inside. And we have, in this particular case, there's 7/16 OSB sheathing on the outside, and then we have a lap siding there. So I want you to draw, either on CAD or Sketch, draw, a wall with its thicknesses. Now, if you don't have the architectural scale right now, that's fine. Just get a regular old scale, any kind of ruler or anything, and draw this small portion of it. Just sketch it out on a piece of paper to full scale. So you're going to have 3.5 inches of a stud. You got a 1/2 inch sheetrock on the inside. A stud is 1.5 inches tall by 3.5 wide. And then you got 7/16 sheathing on the outside. And generally, most of our like hardy board and fiber cement siding and stuff like that. That's going to be about 1/4 of an inch thick, somewhere in that neighborhood, maybe a little bit more. I think it is actually. I think it's about 5/16, something like that. You don't have to really get that super picky on it, but I just want you to understand how the makeup of the wall goes. And when you're in CAD, and if you'll look at some of these things here, I talk about how to draw those things in CAD. So to help you kind of get started there, you can use that. You have your draw commands. When you first open it up, you're going to have your home. And most of all of your work in CAD is going to be done in the home section. Your line, for instance, and you click on the line, and make sure that you've got, let me move this, make sure that you have down here at the bottom somewhere, where is it? Maybe it's not there. You should have dynamics open or running. Dynamic prompt, make sure dynamic mode, make sure that is on so that when you go to put your cursor here, it talks to you. This little thing down here is the way that CAD talks to a human being. And even here, you will see, let me just go over here to this. How can I do that? Leave that there. So let me go. It's going to take it away every time. I know how I can do it. Print screen. All right, so I'll just go over here, open this up, and there. Okay, so you have these, you have it down here, it talks to you, but then with dynamic mode on, then it tells you right there. And whenever you see something that is highlighted in blue, that means that you can actually type in something. For instance, when we're going over here and it's asking me to specify my first point. It doesn't matter where I specify it. I'm going to click, and then I'm going to move my cursor. Now you see that I have highlighted 5 feet 7 3/16 of an inch. Well, let's say that I'm wanting to draw just the section, the end section of a stud. So I'm going to type in 3.5 inches. And if I hit tab, it switches over to my degrees, minutes, and seconds. And I want it at 0. I want to go across. So this is 0 and this is 90. Notice how it changes when I move my cursor. So this is 0. And I can, since I've already put 3.5 inches in, you'll notice that there is a, you'll notice that there's a padlock here. That means that this is locked in place. This is still open, but this is locked in place. And if I'm going in this general direction and it's showing 0 degrees, minutes, and seconds, all I got to do is hit enter. Bam. Now I've got my first movement there. Now I can just move the cursor in another direction, type in 1.5 inches, and then I can keep right on going. And I can draw this without having to worry about it being obscure or off dimension or anything. And down here at the bottom, you have something called snap. So when I've got snap on, you will see that little green square open up there. That means that it's going to snap perfectly to that. If I don't have the snap on, then I'm going to try to get that corner as close as I can. Let's see how I do. Okay, so I've started that, and I'm going to end my line. Now let's go really close in here. See, I was nowhere's even close. I couldn't even get nowhere's close to that. But if I have my snap on, then I can actually, I can go way out here like this. I'm going to move that out of the way, and I'm going to move it back. And because my snap is on, I'm way out here. And I seen that little green box on. Look there. It snapped right to that corner perfectly. Okay, so that's the snap. And if you hit the little drop down beside of it, it will give you the different parts of whatever you have, whether it be a circle, you can get the center, you can get the quadrant of the circle, you can get center line, endpoints, all kinds of sorting things in here with that. So that way you can utilize this to make sure that you are getting it dead on it. So for instance, I want to be able to put a square in here, or I mean an X in here, to show that this is the section view of a 2x4. So if I were to just, if I were to just draw a 2x4, this, I'm going to say that this is a 2x4. All right. So this is obviously looking at the side of it. But if I'm in a drawing and I need to differentiate, the stud from the end of it, then I put an X in there. The X generally represents rough cut lumber. Not to be, if let's say that I've got a piece of lumber here and I'm going to put something else in here, such as this, and then I'm going to, and just bear with me, I'm not going to expect you guys to do this, but I'm going to put this in here and I'm going to copy this again and again and again and again and again and again and again. And this is not something that you would normally do in CAD. I'm just trying to make a point here. So if I keep on doing this, and then I'm going to clean it up here in a minute. All right, so here I have a piece of rough cut lumber, a stud. Over here I have another piece of lumber, but what this is represented by an X. What would this mean? What kind of piece of lumber would this be? Would this also be rough cut lumber? This represents a finished piece of lumber. Okay, so this is going to be nicer. We generally don't put all of this mess in there because obviously it can get very dirty. And well, for instance, let me show you this. When I go to print this, and I'm just going to print the whole, I'm going to print at least this much of it so that you can see what I'm talking about. See how ugly this gets? I mean, it just, it just takes too much away from the drawing. So when we don't typically put all of this stuff in there, and so we could show that this is rough cut lumber here, but down here we have finished pieces. Actually, this piece here should be cut right there. So we've got two pieces of finished lumber here, and we don't put anything in it. So this X represents rough cut lumber. We're looking at the section of rough cut lumber. So like I say, what I want you to do is kind of get used to these scales. I want you to draw a wall, sketch it out, or draw it in CAD to scale as best you can, to some sort of scale. So if you only have nothing but the ruler here, obviously you're not going to be able to draw it at full scale. We might be able to do this much of it as full scale, but then when you're trying to do the entire stud length, then you're going to have to use this, and you're going to have to say, okay, 1/8 of an inch or 1/4 of an inch is going to be equal to a foot, and you're going to have to kind of go through here and calculate that. So for instance, I'm going to open up this construction calculator for a minute, and I want to know, okay, so I've got 93 inches, and I'm going to multiply that by 0.25. Nope, I went the wrong way, sorry. 93 inches divided by 0.25. Or maybe that's what I've done a minute ago. No, that didn't work out either. How am I trying to do this scale? 1/4 of an inch equals foot. 0.25 divided by 12. Maybe that's what it is. All right, so times 93 inches equals 1 point. Now that's too small too. What am I doing wrong here, guys? a 1/4 inch equals a foot. 1/4 inch equals a foot. 0.25 divided by 1, that would give me 0.25 times 93 inches is 23 inches. That's still too big. 1/4 inch equals foot. Let's do it. I know what I'm doing. I'm doing feet and inches. 93 inches in feet is 7 feet 9 inches times 0.25. Yeah, there we go. So if you were using this scale here, no, that's still not right. Let me just think about this. That was 7 feet. 1, 2, 3, 4, 5, 6, 7. That should be 1 3/4 of an inch. Something I'm not doing right. My fractions are not right. So a 1/4 inch per foot, a 1/4 inch equals a foot. That's 7 feet, almost 8 feet. 8 feet would be 2 inches. So 2 inches divided by 8 feet. Got to find a multiplier there. That goes back to that big multiplier there. Times 7 foot, 8 inches. I forgot what it was. Yeah, so that's right. Yeah. I had that right to begin with. So that one multiplier, 0.25, and I forgot how to get to it now. 0.25 divided by 12 equals times 93 inches is 1. There we go. So yeah, I had that right. So that is the multiplier, 0.25 divided by 12. So remember that multiplier, 0.020833. That is the multiplier to get you to our 1/4 inch scale. So let's say, for instance, I was wanting to, well, I could still do this on 11.5 sheet, 11 by 8, 8.5 by 11 sheet of paper. If I wanted to do a 1 inch, so 1 divided by 12 is going to be 0.03083333. So times 93 inches. I could do 7 3/4 of an inch here, and that would be the height of a stud. So use that. You can use your ruler to draw out the height of the stud. So this particular height here, now these are not 98 inch. Yeah, they are too. 93 inch studs through here will give you that. So what I want you to do is try to understand what material would look like drawn out to a specific scale. So let's think about, we can start designing a house. Then we have, in this particular case, for some reason I'm not showing it. In this particular case, this is 12-inch CMU wall. So I'm not going to, even in CAD, I'm not going to draw. So a real 12-inch CMU is going to be 11 5/8. I'm not going to draw this 11 5/8. I'm going to draw it to 12 inches. All right. Some of this stuff we're not going to try to get nitpicky on, because if you'll notice, all of the dimensions come from the outside wall, and that is going to be 50 feet in this case. All right. We're not going to lay out a wall to 50 or 49 feet, 11 and 5/8 of an inch. It ain't going to happen. It's just not, when we're trying to build a house, we want to keep these numbers as simple as possible. So if you'll look down through here, you will notice that the smallest increment on any of these dimensions is 1/2 inch. All right. So I don't want to give the builder any room for error. I want to try to keep it as clean as I can. And so, for instance, let's say, I'm drawing this out, and let me get over to the floor plan for a minute. Let's say, for instance, I'm drawing this out, and we, typically we do these windows, and I've placed it in there, and I'm going to give a center dimension of 6'1 5/8. All right, well, that's not cool. We don't want to get down to 8s, or definitely want to get down to 16ths on this window. So what we're going to do, you would never see this in a house. I'm going to move this 3/8 of an inch, And then when I go to do the dimensioning on this, then it's going to come to 6'2", so that when the builder pulls out his tape measure and he starts laying off of this window, he's not having to deal with really small fractions. Again, 1/2 inch is the absolute smallest that you want to go. So if you have to move that window 1/16 or 1/8, or in this case 3/8, the homeowner is not going to notice that. Well, let's see. In this side over here, we have 2'4", and in this side we have 2'9". They are not going to notice that difference, not unless they pull out a tape measure. Most homeowners are oblivious to stuff like this, even though it's off by what, 5 inches. So most homeowners are not going to be oblivious to that, or are going to be oblivious to that. So try to build your houses to where you have nothing more than a 1/2 inch movement, or the smallest increment is a 1/2 inch. Now, notice also that I'm not dimensioning any of my doors, my interior doors. My exterior doors, let me go over here, sorry. So I've got my, let me explain to you why I'm going between the two. You have a cleaner version here, and that's generally for the homeowner. Even in the basement, I have a clean version for the homeowner, and I'm going to go in here and I'm going to tell them, kind of about what the measurements are here. And let's see how close we are with those measurements. That one's dead on, and that one's dead on. Of course it would be. Let's try it again. Maybe I can get something different here. There we go. All right, so in this case, I don't even know why that says 13.2. It should say 13.1. Change that right quick. All right, so we're not gonna tell the homeowner it's 13 foot 0.5 inch. We're gonna round that off to the nearest inch, and that's all they need to know. Remember that when I'm doing this, these measurements here are going to the stud, to the face of the stud. So let's go down here for a minute. So when I'm doing a dimension, I am dimensioning it to the face of the stud, not to the face of the drywall. All right, so when the builder starts building this, he doesn't have to take away for the thickness of his drywall. He doesn't have to add for the thickness of his drywall. This is it, done deal. So when we're looking at the homeowner, when we're talking with this to the homeowner, if we were to present this with the homeowner, they would have an absolute mental meltdown, because they have no clue what the heck we're talking about. What's a vapor barrier? What's stone base? What is WWF? That's the World Wrestling Federation, right? So we have to keep it simple for them, because they're not technical people. You remember in school you had to write reports, and you'd have to write a technical report, and then you'd have to write an informative report. So in this case, this is the informative report, and this is the technical report. The person who's going to be reading this is going to be the builder, and he hopefully understands everything that's put down into this, all the way down to what WWF stands for, or a number 10 6x6 WWF. And if you're not aware of what that is woven wire mesh number 10 6x6 woven wire fabric, woven wire mesh. You notice that it comes up both ways. Some people call it woven wire mesh. Some people call it welded wire fabric. So this is, that's what that is. And it goes into the concrete. And I promise you guys, if you ever use this, if you ever do any concrete at all, don't buy the rolls, buy the flat stuff. This stuff tends to roll back up when you lay it down. And those ends, if you'll notice in this picture here, those ends, if that thing's coming at you at 30 miles an hour, it's going to penetrate that old skull of yours. So buy the flat stock, and you can buy these and they come in 5x10s. So, you know, when we go into for the homeowner, we're going to keep these all the dimensions, we're going to keep it very, very simple for them. And that's one of the things that we're going to start by doing is when we're, you know, designing a house, we need to keep it simple for us as well. So when we're designing houses, a lot of times we may take a drawing and do bubbles or X's or something of that nature. Let me go in here and open up an email right quick. I want to show you a picture that was sent to me by a client. And this happens all the time. All the time. Whoa, what? That's not what I wanted. Candle framing. There we go. So this is the latest picture that I got. All right. This I get all the time when I'm drawing. Okay. They have no clue how big a garage is. 20 by 22. If you're going to park 2 cars in a 20 by 22. Now, this 20 by 22, is that, where is that? Is that the inside? Is that the inside of the drywall? Or is that the middle of the wall? Or is that the outside of the face of the stud? So these folks, they have no clue what they're doing there. So what I done was I started in a drawing, and, you know, I'm taking information that she's given me, like, for instance, this 12 by, I've got 2 12 by 12 bedrooms here, and then I've got some closet space in the middle of it. So, you know, I can come down here and I can start a box. So basically I went into draw, I hit my little box there, and I'm just going to start it. And I can punch in 12 foot. And if I hit tab, it goes me to the other one, and I can put in 12 foot there, and I hit enter. And now I have a 12 by 12 box. So if I highlight that box, I can copy it, and I have 2 boxes. All right, so we know that so far we have done what the homeowner wants. We've got 2 bedrooms that are 12 by 12. That's what she's asked for here. 2 bedrooms that are 12 by 12, but we have closets in between them. How much space do you need in a closet? You ever thought about that? So let's you know, we're going to measure the side of our, you know, from shoulder to shoulder. How big is that going to be? So think about your clothes. Let me go back over here a minute. Or I'll tell you what, golly, getting all kinds of stuff. Let's talk about a clothes hanger. All right, so, you know, how big is a clothes hanger? So let's find out what Google says about a clothes hanger. Clothes hanger size. How big is a clothes hanger? And of course, we're going to get all kinds of things here. So why can't I just get everything simple? It's going to be given to me in centimeters. There we go. 20 inches. All right. So does that mean that our closet needs to be 21 inches? Probably not. Remember that, you know, when we're hanging up a shirt, our shirt, you know, the arms of the shirt are not going to be in here. They're going to hang out to the side. So we don't want the clothes to rub the center or the sides of the walls when we're putting that in. You know, a lot of times, you know, especially women, they get these enormous closets. They love walk-in closets. They're looking for something. They go in there, and then that way they can pull out what they want to. They look at it, slide it over, pull out another, and they spend about 30 minutes or so trying to figure out what they're going to wear. So when we're thinking about closets, typically for a bare minimum closet, we want closet equals a minimum of 2 foot 3 inches wide. Well, that didn't work out. Let's try it again. 2 foot 3 inches. Closet equals a minimum. Okay, so we need to have 2 foot 3 inches in here, right? What about the wall thicknesses? Now we're starting to think a little more, all right? So we have, let's say that this is the face of the stud. So inside of the face of the stud, we're going to have a 1/2 inch of sheetrock. And then we're going to have the 2 foot 3 inch minimum. And then we're going to have another 1/2 inch piece of sheetrock. And so how much space now? Remember that, all right, let me do one other thing here. 3.5 inch. This is the stud. And this is the other piece of sheetrock on the other side of the wall. This is the stud on this side and the other piece of sheetrock. All right, so we have the stud layer here. We have the sheetrock layers, and then we have our closet space. So we need to figure out from face of stud, remember that we're not telling the contractor the face of the drywall. We need to have a bare minimum of 2 foot 4 inches on the insides between these two. All right, but again, all right, so we were talking about the inside. I don't know why this is so dang small. Let me do one thing right quick. I can just copy this and pull it into another drawing. And then I can copy it. There, now you can see it better. So there's some settings on this stuff, and I'll get into that a little bit later. But right now, what I want you to do is just try to think about your sizes and where they're coming from. So when we talk about a 12 by 12 room, again, where was that from? So let's go and let's add, we're going to say that that's the inside of the room. So we've got sheetrock, we have our stud, and we've got some more sheetrock. No, we won't put the other sheetrock on here. All right, so all of a sudden this building starts getting bigger and bigger and bigger. I mean, we're just talking about one room. And so, matter of fact, so I sent that, I had that drawing, I've got it already done. I want to kind of pull that up and look at it for a minute so that you understand. All right, so here is what I sent to her last night. Now let's go back over to that picture. Here was what they gave me. All right, and I had to, use this information, 12 by 12, 12 by 12, 12 by 4. So this is a bedroom, closets, bedroom, walk-in closet, master bath, master bedroom. And, you can read what these other things are. Matter of fact, she's got this space over here that she wants, but she don't know what it's called. So what I had to do is I had to take this, and I did. I basically took little blocks, 12 by 12, 12 by 4, 12 by 11. And by the way, this first number is always going to be right and left. And the second number is always going to be up and down when you're looking at a plan. So I had to take all of this. And so this is what I ended up with. So you see how big these bedrooms ended up being. She started out with 12 foot by 12 foot. But, we had wall thicknesses that we had to worry about and how things are going to match up. So let's go back over here just a sec. She wanted this office put in here, but she wanted a door here. Now, notice how small this space here is and how large this space here, because I had to put a door, I had to put a closet, and I had to put another door, and I got a bathroom. I didn't even put the door on the bathroom. Doggone it. Dang, I thought I had everything fixed. I sent this to her and there's not even a door to the bathroom. So yeah, I'm finding my own mistakes as well. So, I had to give and take. I had to pull this out in order to get this in here. Well, again, how much space do you leave here? So let's think about how this is going to be built. As a matter of fact, I'm going to, where am I at? I need to go to View, Blocks. And I know that I'm flying through this and, you know, you're trying to, we'll get to there. And it's not going to give them all to me. So I'm not going to waste your time waiting for that to take place. I'm just going to draw another. Actually, I've already drawn it, haven't I? Or did I erase it? I erased it. I got it over here though. Even though it's not to the right scale, but I can fix that. I'm going to copy that and I'm going to take it over here, drop it down, and I'm going to change the scale. There. So when I'm building these walls, I have to think about what's going to happen in this door. So when we're talking about these walls and how the framing goes into them, you can, doggone it. If I can get my hands and my mind to do the same thing, it'll be all right. All right, so, you know, we're going to have these, they're going to be every 16 inches down through here. And, you know, we're going to have those studs in the wall, but how much space do we need here? So if we're looking at this door, and my computer is locked up. Give it just a minute here. There we go. So we've got the door here. So, well, what goes on here? One of the first things is a 3/4 inch board. So this is going to be the casing, and there's going to be some trim that goes over here and over here that's going to go all the way around it. But when we think about a rough opening for this door is a 2868 door, and I'm just going to, man, I'm going to have to close out some stuff. I'm going to close out a couple of things and see if it will run a little bit smoother. I've got too much stuff open here. Man, my CPU is still jumping up to about 27. So I've got a little monitor up here. When you go back and look at the videos, then you can see that. You might be able to see it now. I don't know. So my RAM's at 22 and my CPU's running at 14%. So when I go to lay out these rough openings for these doors, so half of that is 2/8. Or yeah, half of 2/8 is 1/4 plus 1 inch. So 1'5". And so when I'm taking my door size as 2/8, I'm going to add 2 inches to this to get the rough opening. So now I have my rough opening, and you see where I've got a little bit of space in here, and this is going to be the first stud that's going to be in here, and I'm going to have a double stud there. And actually, I've probably not given it enough space there, am I? Yeah, maybe so. All right, so how much space is bare minimum? This is the bare minimum that's needed for a door to the wall. So we have 3 inches plus 3/4 plus whatever that is. So how big is that? 1/4 inch. So we have a 1/4 inch shim space there. So when you're thinking about from the edge of this to your door, you're looking at a total of 4 inches, bare minimum. This door, if built properly, cannot be any closer than 4 inches to a wall, so that we get enough space in here for the components that's in this wall to be placed into it. Does everybody understand so far what I'm saying? Okay. If I lose you or get too fast, you guys slow me down. And this has to happen through all of our doors. We've got to have a minimum of a jack and a king stud on each side for our doors, so that we can hold up the finished trim and then have that shim space in there for the door to operate good. Also, you have to think about, when you're thinking about design, and you'll notice that, and I've had different designers tell me different things. I, for one, generally do a full swing on the door. So, that's kind of, and I've hit the wrong thing. So let me give you an example of what I'm talking about there. Okay, so this door will open up all the way to there. All right, so meaning that this is unusable space other than the door. We can't put a plant, we can't put a TV, we can't put anything right there because that is the space that's going. Now, this door is at full open capacity. Let's open this door at full open capacity and look at what happens here. Look how much space, this is a smaller door by 4 inches, but look how much space it took up here because it's so far. Now, why do we not stick it way over here? Well, because of what we can access as humans on the inside. We need to put this in the center of this closet so we have equal and easy access to both corners of the closet here. So that's why this door is there. But can we put something behind it? Sure. Could we could put even a small piece of furniture behind it even, if need be, as long as it doesn't interfere with the door opening to at least 90 degrees like this one here. But like I say, some designers, and I'm just a draftsman, I can't call myself legally, I can't call myself a designer because I don't have a master's degree. I know it's stupid, even though I do a lot of designing. But some of the people, the designers, when I say designers, I'm talking about contractors and architects, they want it to be shown at a 45-degree angle just because it looks a little cleaner and things don't get lost in it. So when I say lost in it, let's go back over here for just a minute. Let's go with this one. Yeah. Okay, let's go with this one. All right. See how, so the contractor or the designer actually sent me this drawing and I turned it into this drawing. So they sent me the simplified version, but notice that, the sizes of the door are up and down. Well, that's where the walls go, up and down. That's where the dimension lines go, up and down. And if you look, you can see the doors very clearly because the doors are at a 45-degree angle. It's just about the only thing on this drawing that is at a 45-degree angle. So the doors kind of stand out to you a little bit. Well, I take it even further. So instead of the door sizes getting lost in the drawing, because now, from the simple version that was sent to the homeowner to the complex version sent to the builder, I want him to be able to see and understand these sizes, because when he's doing a material takeoff, he needs to be able to go through here and count these doors and know which sizes they are. And with all this other mumbo jumbo going on, if I were to allow these measurements to go, right and left or up and down, then they could get lost and he's going to end up having problems. So I take these doors even to a further step when I do the building plan, the building plans, so that they kind of pop out to the contractor and he can see those. So that just makes it a little bit easier job on him. And the reason that I do that is because I too am a builder. I do some building on the sides. I used to be a contractor with that built log homes. So I've been there. I've done these material takeoffs. I've had to scrounge to find out information, and God knows how many times I forgot different things. Don't want to do that. So when I'm doing these plans, I want to try to keep them simplified as well. Let's look in here. Notice that here is an outside wall, and I'm not showing the stuff that we see on the section. All right, so the sections are at a 3/8 per 1 inch, where these floor plans are a 1/4 inch. So these are smaller. And if I were, look at how this is going to get real dirty really quick. So I'm going to add the 1/2 inch drywall to the inside. And I'm going to add the 7/16 sheathing on the outside. And then I'm going to add the siding. Now, it's not 1/4 inch. What would it be here? Let's see what we got here. I have 1 1/4 inch, and I've got to switch it over to a 1/4 inch. So 1.25 inches times 0.666666667 equals 13/16. All right, so I'm going to come back up here to this wall that I was working on, and now I'm going to do 13/16, and this is going to be my siding on the outside. Now I'm going to converge all of these. Clean this corner up. Now, it doesn't look too bad at this point. Notice where the dimensions are taken from. If I turn on these 2 dimensions, you see that it is dimensioned to the outside face of stud, which is where that little blue dot right there is. That's going to be the first thing that's going to be put in place. We're going to build the foundation. Everything is going to be right there at it. So let's back out. When I back out, it gets messy. This is about the size of a 1/4 inch drawing. If I were to print it out on your computer screen right now, this is about what it would look like. So obviously we start getting dirty looking stuff in here all of a sudden. Let's say, for instance, that we're going to put a brick veneer on there. So now I'm going to do something to make my life a whole lot easier. We don't have to do so much cleaning. I'm going to copy right over the top of this. Change that. Now I'm going to put the 7/16 OSB on the side of it. I'm going to put 1 inch airspace on it. And I'm going to put a 4 inch brick on it. All right. Now, again, whoops, I went the wrong way, didn't I? Try this again. Sometimes I get going too fast. 7/16, 1 inch, 4 inch. Now, I want to delete this one so it goes back to the same color there. All right, now, again, even if we had brick going on here, our dimensions are still taken not from the brick, but from the face of the stud. Now, let me back out here to a 1/4 inch scale and look at how messy it even gets even worse. So we don't want to put all of this information on our floor plan. We want to try to keep it simple for the contractors. So when we're drawing this, a lot of times that's, if it has brick, that's all we're going to show. We're going to show the stud wall and we're going to show the brick, and that's it. We ain't going to show the drywall. We're not going to show the sheathing on there. So when it comes out, obviously we are not going to be dimensioning to the inside of the brick. So he knows that he's got to build a stud wall first before he can put brick on it. And then that way it works out better. Now, let me trying to think, where would that be? I better not. I'll try to find it later. I was going to try to show you an old drawing where I drew it by hand years ago, but that just, I might find it and I might not find it. What I do want to show you is, so let's see. I want to match this. I want all of these to be the same color because then I'm going to print it and I want you guys to see the difference in it. So Control P, window, and I'm going to print this to where it prints it off in a 1/4 inch per foot, and look at the preview of this. All right. So if I were looking at this, you know, here's my stud wall, nice and clean. My dimensions come in to the corner of that so that I know that this is the face of the stud. Now let's go over here to this one that I added the brick to, and you see how by adding, saying, oh, this is brick, this is not brick, it gets a little dirty. And so we tend, over the years, we have tended not to put in this hatching to say that that's brick. And instead, we're just going to pop a node in like so, and do this again. See how much cleaner it looks? Okay, I've said this is going to be brick, so that if the contractor is going through here and he's looking through all of this, then he's going to automatically know. And this is not going to be the only time that I'm going to say this is face brick. You know, I may say it several times throughout the course of this, just so that he knows what's going on. And to give you an example of that, when I go into the framing plan here, all right, so I have vaulted ceiling here and here. Let's see. This maybe not be the best one. Yeah, then here we go. So 1, 2, 3, 4, 5, 6, 7. 7 different times I've told the contractor that we're going to have pre-engineered floor trusses above, so that he knows that, you know, this is throughout. Nothing changes. And, you know, in this case, I did show that this is going to be concrete. I've said that this is going to be concrete, and that there's a reason behind this. And let me just go ahead and print this off, and I want to show you the difference. Okay, so if we're looking at this drawing, we see that this is concrete across through here. But then look up here at the top. Now all of a sudden we've got these walls up here, these daylight walls that are not. Well, right, there's a great big note that says we have 2x6 stud walls in here, as well as a 8-inch CMU wall down here, a 12-inch CMU wall here. I give the note again over here, just so that, you know, in case he's looking on this corner, well, what is this? He don't have to chase it down. And then I'm telling it it's going to have an 8-inch CMU wall here. So by giving some indications that, you know, this is going to be concrete, where we're going to have some furring walls here and some daylight walls here, without it getting too dirty. We don't want to overflow. We don't want to be able to, what is the old saying? You can't see the forest for the trees. So we don't want to give too much information on here so that we end up losing the contractor in the process that we're doing this. So in your, while you're doing your wall section, sketching out your wall section, what I want you to do is I want you to sketch out your house. So for your homework, what I want you to do is I want you to measure your house, basically, the best that you can, and put it into, you can do it in CAD or you can do it as Sketch. Try to do as detailed as you can. But again, let's not get crazy about it. In this particular case, this particular house, if you'll notice, it is built so that the this is the OSB 7/16 inch OSB. All right, so I have the 7/16 inch OSB, and I don't like for it to do it that way. Come on, give it to me. There. Notice that, and I've got this drawing to fix there. Notice that the outside of the OSB is equal to the outside of the CMU block wall. So when I'm drawing my floor plan, and this is something that you got to figure out on your house, what actually happens is on this particular case, let me find a better one. Yes, okay, you can see it very clearly here. I'm going to take this out so you can see it even better. All right, so this outside wall here, this is an exterior wall, is 4 inches. I've drawn it to 4 inches. And this outside wall is also to 4 inches. But this inside wall is 3.5 inches. Now, why is that? It's because of that OSB. The OSB in this case is equal to that line right there. So this dimension here of 50 feet, which goes from the outside of the block to the outside of the block, is also the same 50 feet from the outside of the wall to the outside of the wall. All right, so I've incorporated that OSB within this wall. So when I'm drawing this, I'm going to draw it at 4 inches. Now, if I'm using a, let's say that I've got a 2x6 wall, then, I have my stud that's going to be at 5.5 inches. Actually, let me just go over here. I've got it on another drawing right there. This, you can really tell the difference in this. Here is a 2x6 wall, which is 6 inches. And then I have an inside wall, there you can see it, that is 3.5 inches. So when you're sketching out your house, you need to take, let's say for instance, I'm going to take a measurement of my bathroom. And I'm going to go from drywall to drywall. All right, and I come up with a number. Well, you need to subtract 1 inch off of that measurement because you have 1/2 inch drywall here and 1/2 inch drywall here, because I want you to show only the studs. All right, you're going to have to kind of figure out on your house, where the sheathing falls on your house. Does it have brick? And where it is equal to the foundation. So go around to an access door or something where you can kind of look at where the foundation comes to it and see, because you need to be able to dimension to your foundation wall. Now, if you have now when I say your house, if you're living in an apartment or something, don't do the apartment. Oh my God. Go to a friend's house or to maybe your parents' house or somewhere like that, where doing a drawing would actually benefit, having a drawing. I don't want you to do it on a house that you're renting or something. Do it on a house that, you know, could mean something that you could go back and use it later. And because I want you to draw the basement and the first floor, I want you to just kind of start with the first floor at this point, just to kind of get in a, you know, in a, you know, just to get your hands dirty a little bit, get some a little bit of experience on how to do this. And you know, if you're not using CAD, don't worry about it. Use sketches. Just do it the best you can. Remember that when I graduated college, I graduated in 1986. CAD I had one CAD class, and the CAD class, I mean, the CAD at the time was the slowest thing in the world. I mean, I could draw it faster than I could ever have thought about drawing it in CAD. But then a person, a good friend of mine, he graduated the same school from the same program 4 years after I did, and he had one drawing class. So the technology has changed quite a bit. And I actually didn't learn how to use CAD until about 2002. So I was, you know, I've been drawing it by hand for most of my life up until now. So, you know, if you're not using CAD, don't worry about it. Just sketch it out the best you can, and just so that you understand how the process goes. But, you know, just know that, you know, when you're sketching it out, when you measure your window, how can I say this? When you're doing your windows, don't draw. Let me show you a picture. Window section. All right, so this is a window section. I don't want you to get this picky on it. All right, so, you know, the window companies, they've got tons of draftsmen sit around to do nothing but stuff like this. How big is this window? Well, this window should, hang on just a second, print screen. This window, when you're figuring out what your windows are, try your best to take this window from, you know, basically from there to there. So, you know, when you're measuring your window, measure the sash, not just the sash, this being the sash, measure to, you know, as much as you can get to, and some of this may be covered up with trim, and you may just have to guess at it. Look at the inside and the outside both, and try to figure out, you know, what's going on. Generally, your like if you look at the outside, it may be a little different from the inside, but you can kind of, you know, just use the both up, just as your best sense there, and try to figure out how to use this. If you have to, if nothing else, measure your sashes and add 2 inches. Whoops, come back here. So in other words, what opens and closes, which is this point here, measure this and then add 1 inch to it on either side. And that's probably pretty daggum close to what you're going to have there. That's in most cases. So that'll kind of help you out there. So when you're, you know, measure your windows, only thing we're worried about right now is the plan. So, you know, when we're thinking about doing a sketch of a plan, definitely don't give me this one line stuff here. All right. So I want you to be able to look at this, already have your wall thicknesses in, how big of a window you're going to be. Go ahead and just put that in feet and inches, much like what I've done here. So we've got a door. This particular door is a huge door, 8 feet this way and 6'8" up and down. Most all of your doors are going to be 6'8", except for crazy houses like this. Let's see. Nope, wrong one. This house. Come on, CAD. Don't fail me now. Okay, there. So look at the size of that door. 2880. Yes, that is correct. That door is 8 foot tall. So this, you know, the ceilings in this house are going to be 10 to 12 foot tall. The smaller, you know, side rooms are going to be 10 foot tall. The insides, the major rooms are going to be 12 foot tall. So they wanted a door that is going to work for them. So an 8 foot door, unbelievable. Most houses, like I say, are going to have an 80-inch or 6'8" door. That's the common in here. And just, you know, put it in feet and inches. If you got a window that's a twin, 3050, that's 3 foot wide. This one single window is 3 foot wide, and it's 5 foot tall, and it's a twin. And you have triples, you have quadruples, any number of things. Actually, do I have? I'm thinking I had a quadruple somewhere. Come on. When I get off of this Zoom, I'm going to restart this computer because something's happening. It's slowing down. That one is not. What about that one? No, it doesn't either. But then, you know, we have trap glasses. Well, some of you guys may have trap glasses, and you know, this doesn't have a second floor on it, so I don't really show the traps. So I just kind of draw them out in the elevations there to kind of give the dimensions of what they're going to be ordering and so forth. So anyway, so I'm going to shut up now. And remember that we do not have class on Monday due to Martin Luther King Day. So you've got, you know, a good week to measure your house and try to sketch it out as best as you can. And so, you know, go back and look at this video again and again and again to get you some ideas on how stuff, you know, don't worry about the specifics. If you don't know the symbol for something, make up your own symbol. Most symbols, and this goes back to sign language as well, most symbols and sign languages mimic what it actually looks like. So, you know, you don't have to get picky on these windows. Just, you know, a single piece of glass there would be fine. As long as you and I understand what's going on, we're going to put a window in there. You know, doors don't have to be perfectly thickness. Now, if you're doing it on CAD, it's a different story. You've got all those. And well, right now I don't expect you to because you don't know how to use CAD. So just do the best you can. That's all I ask. Either on CAD or sketched on a piece of paper, or you can use SketchUp. You can download some real simple house applications and stuff and play with them as well. So you've got all kinds of stuff at your disposal. And Larry, we'll try to see if we can't figure out how we can get you into CAD somehow or another. And we'll work from there. So also, real quickly, if you got a vaulted ceiling, show me the center line, you know, let me know that it's vaulted, and those kind of simple things. Anybody got any questions? Okay. I hope I didn't blow you away. I know I'm moving across through things a lot, and I'm not explaining, you know, everything verbatim. But if you'll look at those two, watch those two, these two videos here will help you get started in CAD. Outside of CAD, sketching, like I say, again, just do the best you can. If you got a framing square, you can keep it square. If you got a T-square, that'd be great. Or one of those little rolly rulers or so forth. So again, you know, don't forget about your throwaway item. Keep researching that, keep working on that, and hopefully we can get some good ideas with that as well. Okay, guys, I'm not going to keep running my mouth, so utilize this time to move forward with your lab.
All right, thanks, Eric.
Have a good one. Have a great weekend, and we'll see you next week. Next Wednesday. Don't forget, we're no classes at all on Monday.
All right, see you Wednesday.
All right, bye-bye.